Hello everyone. Today we will be discussing how we can generate context-free grammar from the given language. Okay, so let us consider the first given language. Say the language given is this: a raised to n, b raised to n, such that this n is greater than equal to 0. So this means that we can have A and B, or basically A and B are equal in number, which can be first of all either 0. So if this is 0, in that case we will have epsilon getting accepted. Otherwise we have AB. If there are two A's, it will be followed by two B's. If there are three A's, it will be followed by three B's, and so on. So these are basically the strings that will be accepted by this language. So if you see here, we are increasing AB every time. So this is implemented, or this is written in grammar such that first thing we can accept an epsilon. So this is OR. And then we need to write a rule wherein we can produce AB more number of times. So we have A and B, and then we create a recursion by writing S. So this S allows, since there is S on the left hand side and here, the moment we do the further expansion. So let us have a quick look here. So if I expand the uh, S using this rule, and then this A and B are here, and this can be expanded using epsilon, giving me the string AB. Next time, if instead of expanding this using epsilon, if it is expanded again using the rule ASB, it has allowed addition of AB at the center, and making this epsilon gives me this string. Next time, again, instead of epsilon, if this was expanded using ASB, again an AB is added at the center, and making this epsilon makes us accept this string. So this S here basically is allowing us to create addition of AB multiple number of times. So this is how we can write the production rule corresponding to this given language. And since grammar contains listing out the set of non-terminals, we'll write the set of non-terminals V, set of terminals. So the terminals accepted by this language are A and B, and there is only one non-terminals, which is the starting symbol. Okay, so this was for A and B n greater than equal to 0. Now, quickly we can also solve it or write a grammar wherein my condition of AB is greater than equal to 1. So if I say greater than equal to 1, I need to have at least one AB. So the least possible string here instead of epsilon is now AB. So instead of writing epsilon, we'll write AB, which is the minimum accepted string, and the recursion remains as it is. We can still have the expansion of AB any number of times greater than. So this will be the production rule corresponding to the second language. So now we'll have a discussion on a few more languages and try to obtain the context-free grammar. Okay, so let us discuss the next example here. Now, let us try to combine the previous two and see how the next grammar can be generated. So this is the next language. Now, here we see that we need to have at least one A because A is governed by variable n, which should be greater than equal to 1, which means at least one A is mandatory. Followed by B, how many number of B's? We can have 0 or more number of B's. Now, if you look at this language, we need to have A's first and then B's. We cannot have B at the beginning. So, whenever we write the production rule, it should be written such that it accepts only the strings which will be valid for this given language and do not accept any more extra strings. Okay, so now since we need to follow this sequence A and B, what we can do is we can have or introduce two non-terminals now. So one non-terminal will govern this n condition and the other will govern the other condition of m. So now this A is basically governing my A raised to n. So how many number of A's do I need? I need at least one A, and then we create a recursion of A which allows me to increment the number of A's any number of times. And this B non-terminal is for this m times occurrence of small b. Now epsilon is allowed and we can have any number of b's which can be done by writing this recursion. So this is the grammar that can accept the language which is generated here. Let us look at another language. So now let us have more than two terminals which this language allows. So now I have A, B, and C, three terminals. A, B are governed by the same variable n, and C is governed by another variable which is m. And the conditions are n should be at least 1, which means I need to have at least one A and one B. And for M, that is C, we can have 0 or more occurrences. Now, since A and B here are governed by the same variable n, we can use a single non-terminal for them. And C is not dependent on AB because it is governed by M. So we can have a non-terminal B. So now again S gives AB. I need to first expand this A, and this A here is for having AB, and AB can be placed in recursion here, and the minimum allowed is AB because I need to have it at least greater than equal to 1. And B is just the recursion of C, but the minimum allowed is 0, so this will be epsilon. So generally, when we write the grammars, we try to introduce non-terminals in the production rules such that they allow me to have the sequence. So here by introducing A first, am ensuring that A, B comes first in the string, which will be followed by B, which is C. So if you see there is no or here, right? So it will be A followed by a mandatory B, which can become epsilon later on because of the grammar condition. Okay, so let us take a similar example. Now let us have another terminal added. So again, let this be an, maybe bn, c governed by m, and another variable cell d governed by m. And this time let us make the condition as greater than equal to 0 for both the cases. Okay, but then however we need to have AB first governed by n, because number of A's should be equal to number of B's. Next we need to have C and D in equal number. So let this be governed by A and this by B. So we need to find the dependent terminals, and they can be grouped in, or we can write the rule corresponding to that in a single non-terminal, which will ensure the sequence, and it will also ensure that they uh, follow the same variable n. So A is there to increment AB with a recursion. The minimum accepted is epsilon because they can become 0. And B is there to increment CD. So for B here we have the recursion and we make this as epsilon. So this is the grammar uh, production rules which will be generated. Obviously, you will have to list down that set of non-terminal contains S, A, and B, and the set of terminals would contain A, B, C, D, and the starting state is S. So let us take a few more examples before we wind up the discussion. Okay, so up till now we have seen that the languages have fixed start, or they had a fixed start of A. But then now let us see a few examples wherein we are not having a fixed start of A, B, or anything else. So this is a language which says it accepts W, such that this W belongs to 10 star. So 10 star means it allows 0 or more occurrences of 1 or 0. So the terminal symbols which are there are 0 and 1. The non-terminals we would be introducing, S we will be introducing. So, what is accepted here? It says W. Epsilon is accepted because 0, 1 can come 0 or more times. I can have only 0, I can have only 1. And then there is no restriction to this length because it says star. So, this can come up any number of times. So, I can have 0 followed by ones, 0 in between. I can also start with 1, have 0. I can have any number of zeros. I can have ones followed by zero. So there is no sequence which needs to be followed. It is simply W which can accept 0 or 1 in any order for 0 or more number of times. So the grammar for this language would be very simple. We say that we can start either with 0 or we can start either with 1. So if I start with 0, I can expand it anyhow further. If I start with 1, I can expand it anyhow further by introducing this recursion by adding S here. And then the minimum accepted is epsilon, which can accept a null string. So the set of non-terminals is S, starting state is S. So this was a normal W language. Let us do a small change in this language, and let us see how the grammar changes. So now what we say, instead of having only W, let us consider the language to be WWR. So this is reverse. So if I write W, it should be followed by WR. So if I write something like 0, 1, this W should be followed by its reverse. So I'm not talking about complement, it is just reversing this. So this is 1 0. So if I had 1 0, this reverse would become 0 1. So if you observe here, if I start with 0, I end with 0. If we start with 1, we end with 1. So this is how the reverse operation is done. So if I start with 0, I should end with 0. If I start with 1, I should end with 1. So this is the recursion that is created. And then I can accept epsilon. So this is adding epsilon here. So this will be the grammar production rule for WWR language. Let us take one more example here where the language is say W some C separator in between these two, and let this now okay, let us change this to AB this time. Now again, this is a star here, so this means 0 or more times I can have either A, B in any sequence. So now what is it telling me that if I have AB, I will have a mandatory separator C in between and then their reverse, which is AB. But the logic of starting with A or B ending with B remains the same. So the production rule that will be generated is A. If starting with A, it should end with A. If starting with B, it should end with B. And then to terminate this or at the center, we can only allow C and only one time. So this is the production rule that will be generated for this language. So this is all about getting grammar from the language. Let's see if I can make another video to have more number of examples covered. Till then, happy learning.